Hey, so I hope this homework didn't cause you too much difficulty. To be perfectly honest, this homework dealt with a lot of timing diagrams, which we're not going to use all that much, but there really isn't much I can ask you for homework problems on the gates other than, what is this gate? What does it do? So if it freaked you out a little bit, that's okay. Like I said, we're not going to do much with timing diagrams, at least this early. But let's go ahead and just go through them. So the first one said, a combination of inverters is shown. So notice we have a whole big circuit here built. If a high is supplied at point A, so let me go ahead and indicate that here. So if we have a 1 coming into A, determine the logic levels at points B through F. So the easiest way to do this, in fact, when we get to solving bigger circuits that are more complicated, I'm always going to encourage you to do this, is to just write at the output of every gate what the value should be. So if I have a 1 coming in here, and this is an inverter because it's the triangle, and most importantly it has the bubble, that means B is going to be 0 because it's going to take that 1 and invert it to a 0 at B. Now the next inverter has a 0 coming in, and so it's going to get inverted and turned to a 1 at C. Over here, this is going to go to a 0 because it has a 1 coming in and it's an inverter. And finally, our value of E is going to be a 1 because that gets inverted. Down here, we have a 1 coming in here, and so that gets inverted, and we have a 0 there. And so that's it. But like I said, it makes these problems much easier if you just write on the actual circuit what the values are. And so this is that timing diagram we were talking about. And so the idea here is I'm looking on what's something called a logic analyzer, an oscilloscope, which is something that lets me see the voltages throughout time. So basically time is running, and I see this on one signal and I see this on the other signal. What it wants me to draw is what would X look like if that were the output. So the first thing we want to do is we got to remember what this is. Notice it's got a flat back and it's nice and rounded in the front, and so this is an AND gate. And so what I want to do first is write out the truth table for an AND gate because that'll help me. And so we have 0, 0, 0, 1, 1, 0, 1, 1, our output of X. And so remember, if we have an AND gate, that's only true when all of its inputs are true. And so this is false, this is false, this is false. If A is 1 and B is 1, then it's a 1. And so now I know my signal here, X, is always going to be low, except when they're both high. And so notice in this section here, they're both low. Yeah. This section A is high, but B is low. And this section here, they're both high, so it's going to go up. Let me erase these because I think it's getting more confusing. And so when they're both up, it goes up. B comes back down. They're low here. They're both low here. A is high and B is low here. At this section, they're both high, and then it goes back down. So that's one way that you can solve these problems, is essentially you can go through each section part by part and see, is it 0, 0? Is it 0, 1? Is it 1, 0? Or is it 1, 1? And fill it out. But what I want to do for the future is show you a quicker way to do this. Instead of doing it this way, what we want to do is look at the truth table. Which is the thing that happens the least frequent? Well, that's when X is 1, right? When when both of our inputs are 1, and our output is a 1, that's the thing that's most restrictive, right? 3 times it's a 0, it's only a 1 once. And so what I want to do is I want to look on the diagram just to find the spots that it's 1. To be 1, both inputs have to be 1, and I can see that B is the one that's the least amount of 1. And so instead of going section by section, all I really need to do is check these 2 spots. These are the only spots on the whole diagram that could be a 1 at the output. And so I check here, this is a 1 and this is a 1, so I know that that has to be 1. I check here and I see this is a 1 and this is a 1, and so I know that has to be 1. I know that since I've just found all the 1 places, everywhere else has to be false, has to be low. And so that's just a little quicker of a way of filling these out. You can do it whichever way you like. Both are correct. Let's try that same way of doing it on this one. And so again, we have a 4 input AND gate this time. And so again, remember, it will only be 1 when all inputs are 1. So that's what I'm going to do now. So I'm going to look for which one of these 3 symbols is 1 the least. And to me, you might pick a different one. It seems like this one here has very few segments where it's a 1. They're small. So all I have to do is look in those segments to see if everything else is a 1. So I look right here. In this part here, all of them are 1s. And so I know right there, it has to be a 1. If I look here, notice it goes down here, so it can't be that. I don't have to look at any of this area because I know it's 0, so the whole thing has to be 0. I'll look in this area. Notice in this area, this is low. So I can skip all this because it's low, and I'll look right here. Notice in this section here, nope, this one's low, so it won't be high here. And notice in this section here, this one's low, so it won't be high here. So by doing that, I know that this is the only spot that it's a 1, which means everywhere else it has to be low. And so again, that's just a little bit of a quicker way of solving these problems. You can feel free to do it however you want. This would be our output X. Show the truth table for a 3-input OR gate. Alright, so I want to show you that shortcut I was talking about for filling out truth tables. Let's do it the old school way first. So I have A, I have B, and I have C. Alright, so we would have 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, what am I doing? Not 1. 0, 0, 1. 1, 0, 0, 1, 0, 1. Why am I writing all crooked? I don't know. 1, 1, 1. Okay, so if this is an OR gate, remember that as long as any one of its inputs is true, the output is going to be true. And so if they're all zeros, this is going to be a 0. But as long as any one of the other inputs is a 1, the output's going to be a 1. So that's how we can fill it out by counting. Let me show you a shortcut to filling out any truth table. First thing I want to do is set it up. So we have A, B, C, and we have our output X. Now, the only thing you have to know to be able to do this is how many rows it needs. And so remember, it's always 2 to the number of bits. So in this case, we have 3 bits, so it's 8. If it were 4 bits, meaning we had A, B, C, and D, it would just be 2 to the 4. Once I know how many rows it is, all I need to do is make the most significant column, so the one all the way to the left, half zeros and half ones. So 1, 2, 3, 4. 1, 2, 3, 4. Then what I need to do is when I go to the next column, I just make it half of that. So the first half of these zeros are zeros, and half of them are ones. Same thing here. Half zeros, half ones. Now when I go to this column, next column, I just do half again. So for these 2 zeros, 1 is a 0, 1 is a 1, 1 is a 0, 1 is a 1, 1 is a 0, 1 is a 1, 0, and 1. And so once you get used to this, it's a much quicker way of filling out those truth tables. And again, just to recap, you start with knowing the number of rows. Then for the most significant column, you make half zeros, half ones, and then you just divide by 2 for each column after. Alright? So what is this funny thing? That is a NAND gate. And you know what? To this day, I still don't have the NAND gate truth table memorized. I'm kind of joking, but no, I'm not sure I could come up with it perfectly. So the first thing I want to do is I want to get the truth table. And so we have 0, 0, 1, 1. See, it even works for just 2 bits. Alright, my output is X. But I don't want to go straight there, because I can't remember what the truth table for a NAND is. I do remember what an AND gate is, though. An AND gate is only true when they are both true. All of its inputs are true. And so if that's an AND, then a NAND must be this. Alright, so now I need to fill this thing out. And what I want to do is, again, I want to look for the case that happens the least. 3 times it's a 1, and only once is it a 0. So this is what I want to try to find. I want to try to find the cases it's 0. It's only 0 when they're both true. So what I'm going to look for is I'm going to look for sections where they're both true. This is painful to look at, so I'm going to start with this one. And so I need to check in this section, I need to check in this section, and I need to check in this section, and that's all I need to check. So I can see that they're both true in this segment. Remember, when they're both true, it's going to be a 0, because this is an AND gate. I can see they're both true in there, and I can see they're both true there. Moving over to here, I can see they are both true here. I can see they're both true there, and I can see they're both true there. And then the same thing here. They're both true here, and they're both true here. And remember, anywhere that it's not 0, it has to be a 1. So basically, we just need to make everything else 1 to connect it back up. And I hope you guys write neater than I do on the screen. And that's it. That's all there is to this homework. See you guys again soon.